So we will start discussing ISI problems from today onwards. So first we will go back starting from 2025. Okay. So this is the first question. So where it is given that x0, x1 up to xn and so on is a sequence of random variables. Okay. And rho is the correlation coefficient. Okay. And xi is dependent like rho times xi minus 1 and some error terms. Okay. So epsilon 1, epsilon 2, this is a sequence with sequence of random variables with common mean 0 and common variance tau square. Okay. X naught has mean and variance likewise given. Okay. So we have to find the variance of xi and covariance for xi and xj. Okay. And we have to show that covariance between xi and xj is a function of j minus I. The difference between actually j and I. Okay. So any idea how can we solve this? Though I have discussed these questions earlier, in the very beginning of the course. So any idea? Shantanu?
No, sir, actually, I'm thinking.
Okay. So let's start with the solution. So given that rho is in between -1 to 1, that is very common for a correlation bound. So xi is, as I mentioned, depends on xi minus 1 and epsilon I has mean 0 and variance tau square, right? So we can easily calculate the expectation of x naught, which will be 0, right? And variance of x naught will be sigma square, correct? So it is given, right? And what is given above that? X naught, epsilon 1, epsilon 2, all these things are independent. Okay. So now we can write xi like this, and then we further break this xi minus 1 with the same relation, and like that we can boil down, we can take down this xi in terms of x naught, epsilon 1, epsilon 2, and likewise epsilon I. Okay. So from this you can see that if you take the expectation, then the expectation will come out as 0 due to as and correct. Have you got it? Now we will start calculating variance of xi. If you take the variance of xi and take the variance in this equation, the right side expression will be break down in like this, as all these things are independent. So the covariance will be 0, right? So due to independence. Correct? Now the straightforward thing, we have taken out the constant terms like rho outside in from each term, right? And then we calculated this. Tell me if you have got it till this point or not. I'm not getting any response from any of you.
Yes, I understand.
Okay. So this is the expression for the variance of xi. What is given? Now for the part B, we have to calculate it. We need to calculate covariance of xi and xj. Okay. Then in the similar way, I have written down xi and xj, right? Now what can we do? Given that I is less than j, right? So we can bake in the expression of xi in the expression of xj like this. So j will be dependent on the each of the terms below xj. So xj minus 1 like that till I, and beyond that till x naught, right? So here we baked in I in this equation of xj. This is j, okay. Yes. Okay. Tell me if you have got it or not. Okay, then what can we do? Any suggestion? Hmm? Tell me. Navya. So what is the basic definition of covariance? Expectation xij minus expectation of x into expectation of xj, right? So we have calculated the basic terms and showed it. a- So this is actually evident as x naught and all epsilon i's are right. So this is quite trivial, correct? Are you getting this? So now if I multiply xi, okay, with this xj, now what will happen? Sorry, this xi. This is xi, okay. Tell me, if we start multiplying this xi term, so from the first term, what can you see? So x naught square epsilon I, sorry, epsilon. I am saying rho to the power I and rho to the power j, correct? Then we only get x naught square. Otherwise, what will happen? Tell me. We will get x naught multiplied with any other epsilon I, correct? And we have seen that expectation of those will be 0. So the effective terms will be the square terms, right? The expectation of square terms, and the multiplied terms will be 0, as correct, even if this thing also, correct. Then we have this equation, and then nothing, we have done nothing, we just simplified it. How we have simplified it? Simply, I mean, so we have taken it as I plus j and calculated the power, right? And then what we have done? Tell me. We have put the values of a x expectation of x naught square, okay, and take common tau square from each term, okay. Tell me if you are getting this or not. Why tau square? Anyone?
We
Anthony?
are relating with its variance as expectation is 0.
Sorry,
We are relating it with variance because
we are,
variance is E.
huh? Sorry,
We are relating it with variance.
huh? We are putting the values only right now.
Yeah, actually, as the expectation is zero, EX square becomes
Hmm.
equal to the variance.
This is 0 and right. That's why. And then we get this term by adding up the GP, right? And then we have taken the common and ultimately reached up in this expression. So here, this is a constant term, known term, right? And the this expression only depends upon j minus I. Okay, so this is a function of j minus I and hence proved. Tell me, you have understood this or not? So a data set is given for 12 sample cases are there. Okay, this is a bivariate sample XI YI pairs. Okay, and there are 12 observation points, and it's given that we have to determine with justification the values of A and B that minimizes the sum of absolute errors. Okay, how are you getting this error? So there are some equations like this, right? I'm just writing it in here. YI something is like, and what will be epsilon I, right? And then we are minimizing actually the absolute sum of errors. All right. So what we call this mean deviation, right? So when mean deviation is minimum, if this term is the median, right? Any doubt on that?
No, sir.
Piyash?
No, sir.
So the all the thing we have to do here, we have to find the median of yi, right? And we have seen that yi equal to a plus bxi, right? So, and we know median of yi is equal to median of xi. We know this thing, correct? So we will use this thing. Okay. Okay. So again, I'm just repeating the data problem. So this is a bivariate data with 12 observation points. Okay. And we have to just minimize the sum of absolute errors. Okay, that is, if y is related like a plus bxi plus epsilon I, which is an error term, we can write up the error term as yi minus a minus bxi, right? And then we are taking the sum. Okay, so we can see from the given data xi is 21 for I equal to 1 to 5 and 35 for 12, correct? So let y21 be the set of values for xi equal to 21. That is y21 equal to, tell me, 33, 19, right? And y35 be the set of values for 58, 14, 32, 12, 44, 45, 62. Okay. Now we need to find okay. So median of the set y21 is what? Let it write over here. Of the set, this one. So now if we can sort the set 19, 33, 34, 48 and 19. Sorry, 93. What is the median over here? Tell me.
34.
34. And for median of y35 is, if we sort that out, what 12, 14, 32, 44, 45, then 58, 62. Correct? So what is the median over here? Tell me.
44.
Now the relation I was talking to, median of yi will be a plus b median of xi. Correct? Tell me, are you getting this or not?
Sir, why it is median of xi? Because yi does not equal to a plus bx.
Sorry.
I mean, we have to find the absolute value of yi minus a minus bxi.
Mm-hmm.
So, median of yi must be a plus bxi, not median of
Correct.
xi.
Just a second. Tell me once more what you are talking. Sorry.
I mean, y is not is equal to a plus bx, right? So we cannot write the median of yi is equal to
Yeah,
a plus
correct.
b into median of x.
Right, right, right. So we can actually, we are trying to find out this thing. Okay, just leave it that. So we need the median of yi, right? To minimize this thing. Right? You agree on that? You agree on that, right? Piyash?
Yes.
Okay. Then we have two equations. Anyway, I am not writing it like that. One equation is okay. Then from these two equation, if we can solve this, what happens? 10, 7, and from 1 A equal to 34 minus 21B, that is 34 minus. Okay, got it. This is the solution. Tell me, Piyash, if you have any doubt.
No, sir. Sir, do we have to show that the absolute value is minimum when that C is the median?
That you may show, because that is the key point, right? Because
Yes,
we are dealing with the actually basis this result, we are build up the solution, right? We
yes,
are trying to find out the median when x is blah blah blah, and we are
mhm,
trying to find out the median of yi when x is 35, right?
yes,
There are actually two groups. We are break it down into two separate groups, right?
yes.
That's why you have to show actually.
Okay,
So if you break, we are actually what we are doing, we are taking two groups, means I equal to 1 to 6 or 5,
5.
yi minus alpha, okay, plus I equal to 6 to 12 yi minus beta. Do you agree on that? This
Yes.
is your actually, we break it down. So
Hmm.
we have to find
Hmm.
alpha cap and beta cap
Hmm.
in such a way these L minimize, okay.
Hmm.
So that should be alpha cap and beta cap should be the median of y for respective groups of x's. Correct? This is the theory behind it. Actually, right? Then we are trying to find alpha cap and beta cap. And alpha cap and beta cap are such that 21 this was right, and right. So that's why I was talking to, we have to find the median of y. That's why I was writing down that thing. Anyhow, so this is the thing. This is not alpha, this is a. So basis these two equation, we have found out a cap and b cap. Okay. Now this is the problem 2. So we have to find the number of functions from 1 to 2n to 1 to 2n. Okay. So satisfying fi is not equal to I, and f of I is I. Okay. So from this, can you say that f is a bijective function? Tell me. Think and tell me. If I claim f is bijective, okay. So if possible, let f is not bijective, then for I1 and I sorry I2, f of I1 f of I2 equal to j. Okay, but f of I1, okay, equal to I1, that is f of j is I1, and similarly f of I2 is I2, and f of j is I2. So f of j equal to I1 equal to I2. So, and we was initially I not equal to I2, there f of I1 j. Okay, hence f should be bijective. Got it? I'm not. So this is the thing I discussed in this with a nominal way. Okay, then tell me how can we, this is a, now this boils down a problem of permutation combination. Okay, just look at it, and I'm coming in 5 minutes, and then tell me how we can use permutation combination over here. Any idea? Yash? So this should be a good practice. If you can't figure out for a generalized number like 2n, then take a small example, even if in the examination, that makes your, if I mean, solution more quicker. Okay, so what have we done here? So we have taken n equal to 2. Okay, that's a small example, right? Then we have tried that if I find all possible functions from 1 to 4 to 1 to 4, okay, so here we have to actually break down in two groups, right? Are you getting my point? Why a group is necessary? So we have to find these two numbers which will refer in a round robin way. So if you put f over here, you will reach over here, and putting double f, we will go back here. That is the main motto of this, right? And fi, and this should be ij, and these can't happen. Okay, we can't go back like this due to this condition, as fi not equal to I. So we have to pair some two numbers. Okay, That's why our solution is like that. We have to choose first two numbers from four numbers, 4C2, and then we have to again choose in a 2C2 way. Okay, but just look. Now you tell me, okay, you tell me why I have just divided it by 2 factorial. You tell me. Shantani?
Actually, if we are looking, actually, if I comma j gives a thing, then j comma I will also give the same thing. That's why we,
No, I am not doing that. No, we are just uh, I mean we are choosing. So there is no ordering. So 1 2 and 2 1 is doesn't matter over here because we are dealing with combination C. Tell me now. This is order nullify the order of choosing pairs. Tell me, have you understood or not? So 1 2 and 2 1 is not a lookout over here. So from 4, okay, you are choosing 1 2 first and then 3 4 first. Okay, so you can choose 3 4 first and then 1 2 in the second way. So these two things are similar. So you have two such pairs, and this is the occurrence of the pairs. Okay, so 1 2 3 4 and 3 4 1 2 is the same thing. Are you getting my point? So there should be n pairs from, sorry, among 2n elements. Okay, so pair can come in any order. So that's why we are dividing it by n factorial. Are you getting this or not? Tell me. So what is the value of 4C2? Can anyone tell me?
it is 6.
6. Hmm. Can you tell me what can be the ways? So we have to choose any two, right? Tell me any two. How can you choose? So first you can choose 1, 2, and then 3, 4 will be your automatical choice. This is number 1. And then 1, 3. Then what will happen? 2, 4. Number 2. Okay. Then, okay. I cannot write over. So to understand it, I am writing over here. Number 1 is 1, 2, 3, 4. Number 2 is 1, 3, 2, 4. Number 4, 3, 1, 4. And tell me what is this? 2, 3. Right? 4 is 2, 3, 1, 4. 5, 2, 4, 1, 3. 6, 3, 4, 1, 2. So look, this thing and this thing from a function point of view are same, right? So we can ignore any one of these, right? So we have ignored this. Now look this thing. 2, 4 and 1, 3. That is already in point 2. So we can ignore this, right? Are you getting my point? And 2, 3 and 1, 4 is already there in the third. So we can ignore this. So 6 by 2, it will be 3. We are ignoring the order of the occurrence in between among the pairs. So got it? Why we have multiplied it by 2 factorial? Tell me. Should I explain more? Piyash?
No, sir, it's clear.
Shantoni?
Yes, sir, it's clear.
So, whenever a big problem will be given in general terms, it's always recommended to take a small n and then you use your brain and then again generalize it. So, we have generalized it with n, and this is the result. And I need not explain these two lines because these two are simple calculations. I hope this you can understand. So we are done with problem 2, problem 8, and problem 4. Moving on to the next problem. We will do one more problem today, then we will stop. So problem 6. It's given that pi is a permutation of 1 to n, where n is greater than equal to 2. A pair ij with I less than j is called the inversion with respect to pi if pi I is greater than pi j. Okay. Let x denote the number of inversion with respect to a permutation chosen at random from all possible permutation. Then we have to find the expectation of x. Tell me you have got it or not? The problem. So pi is a permutation of 1 to 1 up to n, and a pair ij with I less than j is called an inversion with respect to pi if pi I equal to pi j. So this is your pi. Okay. This is the pi 1, pi 2 up to pi n. Okay. These are the positions 1, 2 up to n. Right. So for I less than j, suppose these two. So take again, take I j equal to 1 and 2. Okay. So if pi 1 is greater than pi 2, then it is an inversion. Right? Are you getting my point? Tell me. So it can be 1, 3. If pi 1 is greater than pi 3, then it's also an inversion between 1, 3. Right? This is inversion between 1, 2. Correct? So we are taking a indicator function where it is 1 if pi I greater than pi j for I less than j. The same thing I have told over here, and 0 otherwise. So tell me, pi I will be greater than pi j. The probability of this thing will be simply half, because there is no chance of getting it equal, right? Either it will be greater than or it will be less than, right? Very simple thing. So then what is the value of x? X is the number of inversions, right? So we will sum it up for all possible values of I and j, right? And then this is this thing, and we can pair it up in NC two ways, and probability is half. Very simple. The problem statement is, I mean, quite, I mean, what can I say, complex type of thing, but the solution is very easy. Correct? That's the, so we will start solving this problem in the next class. Okay. Again, this is also I have solved in previous classes, and all of the above which I discussed today is the revision of old classwork. Okay, hopefully you have got it. Okay, then bye.
Yes, sir.
We will start solving from this one today. So here in this problem, it is given that f is a R2R function, differentiable function with derivative f dashed. Suppose if naught is equal to 0, okay, and f dash x is greater than fx for all x. So we have to prove e to the power minus x fx is an increasing function on of x on 0 to infinity. Okay, so here we have taken a function e to the power minus x into fx as gx. Okay, then we have taken the derivative of g dash x, and as you can see, f dash x always greater than fx is given, right? Basis this, and e to the power minus x is always greater than 0. We have commented over here that gx is increasing. Okay, so that was the first part of the problem. That was very easy one. Okay, so for the second part, what we did, so we have found that z0 is 0, right? Because e to the power 0 is 1 and f0 is 0, right? Hence, we have seen g, g is an increasing function. Okay, so due to that property, g for x greater than 0, gx will be greater than z0, that is 0. Okay, so fx is, if I take the reverse thing, fx is e to the power x into gx, and first let's see, we have to show that limit fx tends to infinity. Okay, so let fx is equal to e to the power x into gx. Okay, so we can write this from here, right? Then we are assuming, uh, as g is strictly increasing, so gx is strictly increasing function, so the limit may be a real number or it doesn't have a limit, right? These are the only possible options for a increasing function. Do you agree? If g is bounded, then it will be a real number, or otherwise, if it is unbounded, then the limit of gx will tend to infinity. Do you agree on that? Yes.
Yes, sir.
Okay. So case 1. So in this case, we have taken that limit L will be a real number. So then, as I said, then gx is bounded on this thing. But if you can see, if you take limit on this will give you infinity, right? So for case 1, it is infinity. And if gx is also infinity, okay, so then it will be always infinity, right? Because e to the power x is always tends to infinity, and gx will also tend to infinity. Then the limit will be also, the limit will be infinity only, right? Have you understood this? Okay, so we have done problem 1, problem 6, problem 2. So 1, 2, 6, 8, and this is 4. So we have done in this note 1, 2, 1, 2, 4, 6, 8. Right? If I am not wrong, this is problem 4, 8, 2, 6, 1. So 1, 2, 4, 6, 8. Here in this note. Okay, then we are coming to this one. Today we will solve the left out problems from that question paper. So, have you seen this question before? Anyone? Have you seen the ISI PSB paper of the previous year? Shantani,
Yeah,
have you tried solving it?
yes, but I haven't solved this one.
Yes.
Sir, I
Yes, sir.
have not solved.
Sorry, you couldn't solve.
I haven't tried, sir.
You have tried.
No, I have not tried.
Have you seen this?
Yes, I have only seen the paper, but I have not solved the questions.
Okay. Just read out the question. Take 2 minutes. Then we will start solving the problems. Okay. So let's start. So suppose A is an n cross n real matrix which has n linearly independent eigenvectors, okay, corresponding to positive eigenvalues 1 lambda 1 up to lambda n, okay, and V be a n cross n matrix whose ith columns is Vi, okay, for all I equal to 1 to up to n, and D is a diagonal matrix whose ith diagonal entry is lambda. Okay, parte. Okay, so what information is given in the question? Let's just write that. So you have to write in this way in examination. Okay. Okay. So corresponding positive eigenvalues lambda 1, lambda 2 up to lambda n. Okay. So we have a n cross n Vi equal to lambda I Vi, right? For I equal to 1 up to n, right? So what is matrix V? V is V1 curl, V2 curl up to Vn, and this is a n cross n matrix, and this is n cross 1, right? As you can see, do you agree? Are you getting this? So tell me, what is the determinant of V can be equal to 0? Sorry, can the, I mean, determinant of V be 0? Is it possible? Yashu, Yash,
No, sir, because the V1, V2s are
right.
linearly independent.
So V is invertible, correct? So V inverse exists, right? That is, so what was there? Hmm. So can we write then what is AV? AV is basically A into V1 curl up to Vn curl. What is that? A V1 curl, A Vn curl, right? Look, do you agree? So this is n cross 1, right? Tell me, have you understood or not? And all this one n cross n, m cross n. This will be n cross n, right? Hmm. Now, can we write this as, so this is n cross n, right? And right? Do you agree? So this is V, and let's call this as D. Say D is diagonal lambda 1, lambda 2 up to lambda n, correct? So what have we get? So we have AV equal to VD, correct? So we are left multiplying with V inverse, okay? So A equal to, sorry, T equal to V inverse A V as equal to IN, correct? So what was our first question? So hence proved. So part B. Tell me how can we do this? So show that there exists 2 to the power n distinct matrices B1 up to B to the power n such that B square J equal to A. How can we do that? So we have AV equal to VD, right? So we are now right multiplying with V inverse. So we have so now we have to find to find a matrix B such that A equal to B square equal to V dV inverse. Do you agree? Think how can we do this?
If we take the square roots of the eigenvalues,
Then what will happen?
I mean, we can write V d V inverse. D can be written as the square of root over lambda 1, root over lambda 2, root over lambda n.
Hmm.
I mean, D is equal to diagonal lambda 1, lambda 2, lambda n.
Carry on.
D is equal to diagonal lambda 1, lambda 2, lambda n.
Hmm.
Then can we write that D is equal to diagonal root over lambda 1, root over lambda 2, root over lambda n at whole square.
Hmm. Hmm. Okay. So if find a matrix C such that C square equal to D, then define ning B equal to BCV inverse will give B square equal to VCV inverse VCV inverse equal to V C square V inverse, that is V D V inverse, right? So to get that, let C equal to, obviously as it is related to D, okay, it should be, I mean, diagonal. So C1 up to Cn, what will be C square? Will be diagonal C1 square to Cn square, and it will be actually diagonal lambda 1 up to lambda n. So C will be diagonal correct. So For each diagonal, we have two choices in C. That will give one unique B. So, number of ways we can get B is so B1, B2, B2 to the power n, there will be two to the power n many matrices such that Bj square Va for all values of j equal to 1 to 2. Hence, proved. Tell me if you have any doubt in this problem. So, this is the next problem. Given that x1 up to x2n are independent exponential random variable with mean 1 by lambda, where lambda is greater than 0. Let x order 1 up to x order 2n denote the order statistics of x1 up to x2n. Then we have to show, you can see what you have to show, and you have to show the limit of x order n less than 1 by lambda log 2 minus epsilon will be 0. How will you do this? Any idea? Yes. So given x1, x2 up to x2n are IID exponential mean by lambda, lambda greater than 0, right? So what will be it? Anyone? Quickly, Shantani. Shantani. Okay, Shantani don't know this. Okay, Piyash.
1 minus e to the power minus lambda x.
Correct. And what else do we know? Correct. So part A. How will you do it, Yoshu?
So like x n less than equal to x means like n observations are less than x. So, and the left, the other n are greater than. So
Other inner greater than in. Then probability of I
no,
mean
no. Uh, so nth largest is less than equal to x. So other may or may not be less than, I think.
okay. Shantani?
Yes.
No. What are you saying? Yes, no.
Actually, I don't know actually the CDF of exponential.
Now
I
I'm
was
not asking
deriving.
you CDF, right? I am asking
Then
you what is the meaning of x order n less than x, less than equal to x. And Yashu has already said that. Do you agree with him? Have you heard what he said?
no, actually I was thinking about.
No. Okay. Okay, then you have also thought it. Then tell me what is your thought?
It is actually order statistics. I hope all the x1, x2, and x2n are in order. So
No,
xn,
x order 1, x order 2 are in order, but x1 up to x 2n is not in order, right?
yeah, yeah, yeah. I also meant it.
Okay, then what is your thought?
Then x order n less than x means the CDF of no, no, no. Let me think. If all the x order 1, x order 2 are in order, then x order n less than x must be the all summation of all the x1, x order 1, x order 2, and order less than x. Then that means the CDF up to x order n
Summation
less than x.
from where I mean, we
Summation, not the summation, not the summation. It will be multiplication. I hope so because it is
multiplication.
independent. It is independent, na?
I am not asking, I am just asking you, not asking the probability. I am asking you the meaning of this event, xn less than equal to x. I am not asking you the probability.
Then I don't know what it is.
You don't know what does that event means. You were saying correctly, but suddenly you went into probability.
Oh, then where did I miss it?
Yashu said it correctly. So to show We have to show this. So the event at least n of observation are less than equal to x. So why is this so? So you have x1, x2 up to x order x to n, right? Then you have arranged these numbers in a way x order 1, x order 2 up to say x order n, then x order 2n. Okay, these are nothing but the arrangement of the numbers in the first row. So xn is less than equal to n, and you know all the numbers left of x order n is less than xn, x order n. So x order n less than equal to x implies x order I is less than equal to x for all values of I equal to 1 up to n. So also these are independent. That's why Shantanu was talking of the multiplication of probability and all, but we don't need this over here. So this thing is already given, but this thing doesn't imply x order n plus 1 is greater than x or less than x. Okay, so this doesn't give any info about x order j for all j n plus 1 to 2n. Okay, so maybe some for some j xj is x order j is less than equal to x. So we have at least 10 observation. There can be more than that. Okay, now it's similar. Just let me take some more. So the right side I counts whether xi is less than equal to x, and summation over gives number of observations less than equal to x among the total 2n observation, right? So two events are identical. Do you agree? So the probabilities equal, right? Get it, Shantoni?
Yeah.
Okay. Part B. So let x equal to okay and define yi equal to xi, okay, then right, you get it. Now What is P? Let P equal to xi. What will be the probability of this? Right? And what will be that? What is x over here? Okay. That is, and this is actually base E, right? Correct? As this is a, tell me, positive. So, correct? Then what is given? Now, what we have to find? Uh, Now we have to find Just a second. Hmm. Okay. Let's do it like this. So we have, okay, do you agree on this? Have you understood what I have done over here? We have multiplied, divided both sides by 2n, correct? So what is 1 by 2n summation over 1 up to 2n yi? This is the sample mean, right? Do you agree? This is the sample mean, and this will go almost surely to the theoretical mean, right? Do you get it? That is P is half Tell me. So, okay, do you get it? Hence, just a second. Can you please tell me this expression? What was the expression? Probability of. Are you writing with me, or you are just depending on me for the notes? Shantanu, tell me the expression.
The expression is x order n less than equal to 1 by lambda log log e base so log 2 base e minus epsilon equal to 0.
Okay, so it will be 0. Proved. Can you tell me why I have written this p less than half? Give me a proof. Anyone can prove?
So lambda e is positive, lambda epsilon. So e to the power something greater than 0 is greater than 1. So 1 by 2
Correct.
into, yeah.
So I am just writing it for others. Maybe this is the key point, right? P is greater than half, and I was just trying in some other way using CLT, but I guess this is the, easier, because if you apply CLT, you mean just take subtraction of mean and divide by the standard deviation. Then I was trying in that way. So what happened? You can just check yourself what will happen in that case. Yi, this will be 2np, right? And what will be the denominator? N2npq, right? Root. So root and all are coming. That's why I avoided that path and just did in this way. So okay, and also lambda greater than 0 is given, right? Read the question. So a population consists of 1 up to n plus 1, okay, units for n greater than equal to 1. Consider the following sampling procedure. Start with S naught equal to 1 up to n, consisting of first n unit. So your sample S naught consists of first n unit, okay? Then generate U from uniform 0 1, okay? And if U is greater than n by n plus 1, then define S1 equal to S naught. Otherwise, remove one units uniformly at random from S naught independent of U and add unit n plus 1 to create S1. So, have you understood it? First, tell me. Have you understood the problem? And we have to determine that whether S1 is a simple random sample of size n from the n population or not. Tell me. Shantani,
Little bit.
what have you understood? Tell me.
We have the sample is not, and we have to work with it. And U from uniform 01, U is greater than, if U is greater than from this stage, how will we know U is greater than n by n plus 1?
What are you saying? Yashu, what have you understood?
Sir, I have not done this topic. I have no idea about it at all.
Okay. Piyash? Piyash, are you there?
Yes, sir.
What have
Um,
you understood?
mm, I don't know much about the random and sampling procedure, but I know that the simple random sampling means every unit has the equal probability of
Right.
selection. So
That
we
is
have to we
every
have,
possible combination. So every possible combination have similar probability to come. So say, how should I say? So if my sample observation is 1 2 1 2 3, so 2 will come exactly equal number of samples, 1 will come in exactly equal number of samples. That is the thing. Okay. First, you have to understand a simple random sample that is SRS of size n from n plus 1 units means every subset of size n has equal probability that is okay. How it is coming 1 by n plus 1 chosen, right? We have to prove it. So let's start with solution. We have the population okay. We start initially with S naught, that is 1 2 up to n, then depending upon u, that is uniform we finally obtain S1, right? So what is S1? Equal to S naught if u is greater than, okay, replace any unit of S naught by n plus 1th unit, okay, at random if u is less than n by plus 1. Now tell me What is the probability of this? This is simply this. Correct? So, what is the probability to getting the first case? Right?
Uh,
So, what is the probability? So, here S1 equal to S0. In the second case, what we will have probability of S1 except I, right? What will be this probability? And also, you know, here it will be, right? Right? And these two events will be independent. Do you agree that? So we will remove uniformly just add here uniformly. So we will uniformly replace, that is 1 by n, and it will be n by n plus 1. Okay. So getting any sample will be this, right? So S1 is a SRS from of size n from the given do you get it? So let's stop here today. So we are left with two more questions. I thought I would be able to cover those two also, but that those two will take some more time. We are running out of time today. So we have done today 1, 3, 5, and 7. We are left with 9 and 10. Okay. So just check the solutions from 1 to 8. So we have done 8 questions in two classes. So I will request you to go through these solutions carefully and let me know if you have any doubt. And we will meet next week. So bye bye.
Sir, you is
Yeah. Yash.
Sir, for the sampling distribution sampling, for the simple random sampling with replacement without replacement, which book should we follow?
Sorry.
I mean, this random sampling distribution,
Yeah.
the simple random sampling with replacement without replacement, this stuff. Which book should we follow?
Just a second, huh? Yeah. Tell me.
I am saying that for this is random sampling procedure. That means simple random sampling with replacement.
You can refer to, I mean, Gun Gupta, Das Gupta,
Hmm.
and I mean the normal probability books, fundamental of statistics outline. You can just refer to those.
Okay,
Okay.
okay, okay.
Okay. You may drop out. Yes. Yeah. Tell me.
yes, sir. Sir, so I will just give my background quickly. So, sir, I have already done a degree. It was BBA degree after 12th, but I was not interested in that. So I then changed my stream to like BSc. Now I'm doing maths, BSc maths degree. So I'm in second year. So I just gave the IIT Jam statistics for practice, and I wanted to go to like my main goal was
BBA. Yeah. How much? I mean, you did the full BBA course
yes, sir. I have completed it.
for 3 years.
Yes, sir.
Then you are doing BSc again.
Yes, sir.
Okay.
Because I was interested in this statistics, so that's why I did this degree. So I gave the IIT Jam this year, but like my score is good enough as per like the on YouTube. I saw that I
What
could
your
into
school?
it was 48.66.
Okay.
So, like on YouTube, they're saying I can get into IIT Kanpur. It is possible I can get the top 60 rank. So,
I'm not sure because as far I know, the cutoffs is uh, almost around 80 or something, right? I don't know, 40, 47 is a good score nowadays or not.
no, sir, like um, the they have analyzed the Google Form data and like from their students and everything, the other coaching people, sir. So,
I don't believe on that. Um,
okay.
just so you are, anyways, you are not going to take admission this year, right?
No, sir. If I will get into IIT, then I will exit this degree.
It's not possible. You need to complete some BSc degree in mathematics or statistics or any kind of, yeah, BBA can't give you, I mean,
I checked the eligibility, sir. This year the IIT Jam they have written no restrictions. We just need any degree.
Any bachelor degree.
Yes, sir. Yes, sir. This year,
But what is my recommendation? So, as you have completed 2 years in BSc, then
yes,
stay back 1 more year, then complete your BSc. BSc is of 3 year or 4 year right
three,
now,
3 years, sir.
and then complete 1 year. No, if you have started this degree, then complete this degree. And I mean, if you are okay with losing 3 years of BBA, then why are you rushing for 1 year?
Yes, sir. But sir, like my main doubt was this, like, in I will decide that later if I want to drop or not, sir. Results are also going to come, but like the main doubt was, sir, I want to like try and clear the MStat this year only. Uh, I want to try. So
Yeah,
that's why I needed your guidance, sir. Like, whatever you tell, I will do. Whatever task you give me, I need some guidance, sir. I did self study only uh, for this, so I believe with guidance I can maybe try to clear MStat this year.
yeah, you obviously can, but yeah, just try this kind of problem and solution. Just do the previous year things,
Okay, sir.
read the theories, and that's the thing. So to clear MStat, you have to be very, very clear with the theory
Yes,
of, I mean, what you are doing, and you have to write it. As you can see, in each step I am giving you the reasoning why I am writing this, why I am doing this.
yes, sir.
That's the very important for MStat, clearing MStat examination. That is unlikely to the other exam, right? So
Yes,
you
sir.
have to write the problems, the answers, I mean, very clearly, from one step to another step. What is
Yes,
the thought between these two lines? Okay,
yes,
so
sir.
you have to be very, very clear about it, and you have to not only clear, you have to write it very clearly.
Yes,
Okay, that's the thing. So yeah, just read the theory portions of stats, basic inference, mathematics, and all. So first see the syllabus of the MStat examination. Okay,
yes, sir.
then just try out the previous year questions, then try to find out that which portions you were weak, in which portions you are weak, then uh, decide, based on that, decide that you will focus on which topics. Okay, so yeah, that's
Yes.
the
Sir, I want
procedure.
to know like where to practice from other than PYQ. What should I practice?
There are lots of questions, MCQ questions, the subjective questions. Uh, there, I mean, say, I mean, you have 2 3 months more, right?
Yes, sir.
So these are enough to solve.
But
Okay.
like the PYQ only you are saying.
Sorry.
Uh, you are saying I should only solve PYQs.
I mean, previous year questions.
Yes,
Yeah.
sir. Only those.
So if you want to do more, you can always do more, right? These are the basic stuffs you should do. I am
Yes,
saying
sir.
that. I am not recommending anything. So if you have confidence that if you don't do PYQ and you just you will just read theory, then it's your choice. I am just telling you something that you have asked me,
No,
but
sir.
I am not.
I will do PYQ, sir. But more than that, for subjective question, what do you recommend I should do? PYQs I will do.
So do you know how much years are there starting from 2014 year to 10? So how many years can you count? 10,
Oh,
11, 12, 13, 14, 15, 16, 17, 18, 19,
acha.
20,
Okay.
21, 22. These much questions. There are
Okay.
more than, I mean, 100 and 150 questions.
Oh,
Okay.
okay, sir.
So I don't know you will able to finish those or not.
Okay, sir.
So
Okay, okay.
those
I did
are
not
more than
realize.
enough.
Yeah.
Okay.
Okay, sir. I will do PYQs, and if I can finish, then I will ask for more.
Sure. Okay.
Okay, sir. Thank you, sir.
Thank you. Bye.
Bye, sir.
Which, so 2025. Okay, cool.
Okay. So you can see the question, right? So you can just take a look of the question. So x1 up to xn are independent random variable having common probability density function if theta and theta lies in between zero, I mean in 0 and 1, either 0 or 1. So if not is given as a uniform distribution function, and same, and f1 is somewhat a decreasing function, right?
Yes, sir.
So let's start solution. Just write it as right.
Yes, sir.
So what we are given that, suppose we wish to test, so let's write to test. What we have to test, it's not null hypothesis is theta equal to 0 versus or the alternative hypothesis of theta being 1, right?
Yes, sir. We apply Neyman Pearson.
Correct.
Okay, sir.
So
I have a question. Like, what happens if both the support of x in null and alternate probability distribution were different? Like, if not theta is uniform 0 to 1, and if one theta is 0 to some number k, like in that case also can we directly apply Neyman Pearson?
So what does Neyman Pearson lemma suggests? Tell me.
If
For
not
that you have
one
to tell
by,
me please.
if not one by, not one, if one by if not
Not
greater
greater
than
than
k will yield a MP region for.
So what is the phi function?
Hmm.
What is the test function? Test function depend on this, right?
Yes.
So and your test function is defined with respect to this. If this is greater than some c, then we
Hmm.
reject, right, like that.
Hmm.
So your f1 by f naught, then you have will have some values for 0 x to some c, and some values for c less than 0 less than something 1, right?
Hmm.
Then according, in that way you have to make the calculation. Okay.
Okay.
And as you are testing a parameter, so this is the most unlikely case the support will be different, right?
Yes, sir.
So the endpoint of these should have same, right? You were saying something like, if my if not is c, some 0 to x to a, and then some value for a to 1 and 0 otherwise, like this.
No, no, no. I'm not saying that. I'm saying that for null hypothesis, the support of a distribution f is something, and for alternate, it is something else.
How it
Like,
can be possible? Because f theta is a, I mean family of distribution, right?
yes,
So the structure of the thing should be same. We are playing with the theta, right?
yes,
And this is similar kind of distribution. And if you are saying, so your x should be same. I mean you are saying that the all the support of the two distribution will be different. Then you can identify easily, right? So if I say x greater than 0 is one single support, and some 0 to x to 1 is your different. So as when you will sample something, so if one of the sample is greater than 1, then you can say that easily it is from this distribution, right? There is no meaning of this hypothesis testing. Are you getting my
okay,
point?
yes, sir, yes, sir.
But
If
there
both
is
the
the
distribution
necessity,
is
there is the necessity of the hypothesis testing when you are, confused between two distribution, because the x values are lying in same region, and you have to identify then what is the probability of uh, getting that sample from the f naught or f1. Understood?
yes, sir.
So should I proceed now?
Okay, sir.
So what is the likelihood ratio? Sorry, write it as or just write L1. Correct?
Yes, sir.
Okay. So correct?
Yes, sir.
Let this is T. So Do you know this?
Yes, sir.
And T, just do one thing. Keep negative here. Let it be positive. Okay. Then correct.
So if we multiply with half, then it will be a chi-square. Uh, like
Sorry.
if we keep the minus negative half, it will be a chi-square.
How?
Like
What is the definition of
no.
chi-square?
Minus two
Chi-square, right?
minus 2 log xi will follow chi-square 2. Okay, like we have to multiply
Correct.
4. Then we have like minus 2 summation log xi will give us like chi-square 2n, and then we can find the upper alpha points.
We can find also from this, right?
Yes, but isn't it convenient to find the upper alpha points or lower alpha points from like normal chi-square t distribution?
But we are not putting value over here, right? We are just given, we will write in the notation terms, right? So
Okay.
obviously you can. So for chi-square, you will write 1 minus alpha, right? And we will write something q1 minus alpha. Okay. Like this kind of thing we will return, or we will write, right?
Yes, sir.
Just a second. Hmm. So you are saying alternatively, what we can do is your chi-square 2, right? Correct?
Yes, sir.
So for both of the case, correct? First, let's write this one. So what was our T over here? 2T, right? So alternatively, what can we do? We were writing C over there, right? Just write A. Correct?
Yes, sir.
So yeah, you can answer in both of the ways. So one is this and one is the below. Just writing.
Yes. Well, we know the upper alpha point of I square, so it will be more convenient.
What is the upper alpha point? I don't know the value. Here
No,
to
we don't know the value, but we can look up from the table.
so for gamma distribution there is also a table.
Okay.
Don't you don't have to worry. For every sampling distribution like this, there is a table. Okay. You can also write in terms of this. That would not be a problem. Okay. Let
Okay, sir.
me go to the next question. Next and the last of this paper. Have you tried solving this paper at your own?
I gave this paper last year.
Sorry.
I gave this paper last year. This is my second
So,
attempt.
oh, how was the examination previous year?
It was okay, but I couldn't able to qualify. Well,
For interview, right?
yes, for interview.
How much did you do in the subjective one?
In the subjective one, let me tell you. The subjective, I did question number one, question number not two, not three. I did four, six, seven. I partially did eight. I did nine, and I tried to do 10, but I couldn't able to solve it there. Like it was something related to constraint optimization. Like there is a
Mhm.
constraint of theta 1 plus theta 2
Correct.
plus. Yes,
Constraint optimization is done by Lagrange multiplier method.
yes, Lagrange multiplier. But I later I when I came back home, I also
Your
then
voice is breaking. I don't, Sayan, your voice is breaking.
hello, am I audible?
Oh, your voice was
Is it okay
breaking. I
now?
couldn't hear. Yeah, it is now okay. Can you hear me?
Yes, sir. Well, I also
Yeah.
tried to do the sixth problem, but I couldn't do that.
What is the sixth problem? Can you please tell me?
Like that one. Like suppose pi is a permutation of 1 to n greater than 2. A pair ij with I less than j is called an inversion. And with respect to
Oh,
pi,
that is the easiest
that
one
one.
of.
Yes, I also did try to do the number second, the number of functions f of I like cycle,
But
cyclic.
have you seen my solutions? What I did in the
Oh
previous
no,
classes?
I haven't seen that one yet.
Which one do you want to see? Let's
I
just open that. So let's start from the start. So here
no
we
no
have.
sir. I will watch it later. I'm also doing the ISI problems. I will watch it later. Uh, I I don't want help with 2025 as much. Like, can you start with PSB 2024 question from question one? Like,
Yeah, after this problem, I will start. Yeah,
okay,
definitely.
okay.
So inversion problem was the most easiest problem in this paper.
Uh,
Where
yes.
hopefully it is here.
Uh, Inversion problem, na?
That is the most easiest problem as per this one. This will
Okay.
be the answer.
Okay, I will see it later.
Okay. But are you? What was the status for PSA? How much did you do over there? That plays a key role, by the way.
Uh, PSA was good. Like, I should have marked. PSA, most of them were correct. Like 23 of them, I did more than 20. I did correct. Some of them were wrong. Like, yes, more than 20, I did correct.
Why? What was the problem
Like,
in more than
I
20 is a very good benchmark, and
yes,
then
but
with
my PSB solutions were like not up to like not good enough. Like I did try. Yes, my PSB question number four, I did it correctly. Like it's the easiest problem in the paper. I was having some problem with question number six.
what was that problem? Can you please just read
No,
that?
no, that was like last year. Like I was having facing some problem. Usually my combinatorics part is like a bit not so good. Like combinatory, so I'm not so strong in that part. Like that's why I couldn't able to solve question number two too. I tried, but this one like question number eight, reach regression wala. I tried to solve.
Reach regression.
Means
There was no problem of ridge regression over there.
isn't like yi minus a minus bxi mod when
No.
it mod is
So
there
ridge
it's
regression, we do you know ridge regression? Ridge regression is a
no,
completely
I
different.
tried to solve that using well, I tried to study about the problem and then the chat gpt said it's related to ridge regression problems.
No,
That's what
don't believe on that chat GPT. That you are talking about this one, right?
mini
Let
yes mod summation mod wala.
this one.
Yes, yes.
This is not a ridge regression.
Okay, okay, my
Ridge regression is completely different thing that is taught in ISI. Okay, let's just focus on this right now. So given theta 1, theta 2, and theta 3 are the three angles of a triangle. Okay, such that 180 and suppose each angle is measured by an instrument that is subject to that is yi equal to theta I plus epsilon I, where okay, so the observed values are okay. Find the maximum likelihood estimate of theta 1, theta 2, and theta 3. Right. So, what do we have to do now? So, our theta i's are basically yi minus epsilon I for all values of I, right?
Yes, sir.
Hmm. Just a sec. Okay, just a second. Sorry. I just wrote the reverse thing. Okay. So epsilon I is independent normal variables, right?
Yes, sir.
So these are also independent,
Yes, sir.
since we do have as right. Correct.
Yes, sir.
Where That is, it is proportional with sorry, such that, or right, subject to. Correct? Tell me.
Yes, sir.
So we have to minimize what is y1, 83 minus theta 1 square plus 47 and 56. Correct? Let correct.
Yes, sir.
Then if we partial derivative, what does it give? Just write it plus alpha lambda belongs to R. Did you do in this way, Shayan?
I tried to like I tried to make it to Lagrange multiplier form, like so that I can apply Lagrange multipliers. I knew that somehow I have to apply Lagrange multiplier, but the I couldn't able to get to the point like L equals to 83 minus theta 1 whole square, like this line. So I couldn't able to do it fully.
Okay. Now, what we are found? Just a second. So from here, what we get? Theta 1 is just a second. Hmm. So theta 1 equal to 83 uh, 1 minus is there, right? Correct? Shayan, are you,
Yes,
are you checking my calculation? Please check my
yes,
calculation.
yes. I'm following it.
Right? So theta I equal to yi plus c, where c equal to minus lambda by 2. That is, all angles are shifted by same constant. Okay. Now summation over theta I should be 180 degree, implies 83 plus 47 plus 56 plus 3c will be 180 degree, and this is 5 and 56 13 6 and there 186 plus 3c. Let's just replace it by 3 by 2, lambda by 2, that is lambda equal to okay, finding c is enough. C is -2. So the just a second. So okay, do you get it?
Yes, sir.
So these are the two things. So let's start 2024 from the next class onwards.
Yes, sir.
You also just take a look of the paper and let me know if you have any particular doubt from the those, then we will check that. Anyway,
Sure.
you solve all the problems.
Mm.
Okay. So yeah, any more doubt from these two?
No, sir, not any more doubt from this, but I have doubts from 2023. I have doubts
We
successive
will
problem.
solve one by one. Okay,
Huh?
we will now come to 2024. Then we will
Yes, yes.
come. It will take some two, 3 class. Then in the next 2, 3, we will solve 2023.
Okay, okay.
Okay, let's
Okay, sir.
Let me stop today. Bye.
Thank you, sir.